Hello friends, this is Jim with Science Talk. I have more space news. This one involving potential methane on Mars. NASA's Mars rover Curiosity has definitely revolutionized and improved our understanding of Mars. Now we also know, thanks to Curiosity, that ancient Mars had carbon-based compounds called organic molecules. And of course, organic molecules are necessary for life. A new study published in Science presents the first conclusive evidence for large organic molecule on the surface of Mars, a pursuit that began with NASA's Viking landers in the 1970s. Earlier tests may have hinted at organics, but the presence of chlorine in Martian dirt complicated those interpretations. Basically, what's called chlorocarbons. You got chloral biphenyls, CFCs, chlorofluorocarbons, and so on. That can muddy up analyses. So, Dr. Jennifer Eigenbrody, who is a biogeochemist at NASA Goddard, said, when you work with something as crazy as a rover on Mars, with the most complex instrument ever sent to space, it seems like we're doing what may have been perceived earlier as impossible. Basically, as new methods, new machinery, new techniques improve, new analytical methods improve, we are able to use that instrumentation to expand our knowledge. Curiosity's latest data reveal that the watery lake that once filled Mars' Gale crater contained complex organic molecules about 3.5 billion years ago. Let's stop there for a moment. The age of our Earth is estimated to be about 4.5 billion years ago, and the evidence indicates that bacterial life developed early on in Earth's history, some 3.5 to now 3.8 billion years ago. So we're looking basically in the same time realm. Some sort of liquid body, and in case of Earth, we definitely have some microbial evidence, microbial life. Is it on there? Was it there also at one time on Mars? Stay tuned. But this is very tantalizing. Now, back to what the Curiosity data found. Hints of them are still preserved in sulfur spike rocks derived from lake sediments. Okay, the hints of them referring to the complex organic molecules. Sulfur may have helped protect the organics even when the rocks were exposed at the surface to radiation and bleach-like substances called perchlorates. Okay. When you buy a thing of household bleach and you look at what the main active ingredient is in bleach, you read sodium hypochlorite. So you have perchlorate, then you have the chlorate, then you have the chlorite, then you have the hypochlorite. All of these ions have a -1 charge. The chemical formulas would be perchlorate is ClO4, chlorate is ClO3, chlorite is ClO2, hypochlorite is ClO. Okay. So it's a sequence of that, and you can do the same thing per bromate, per iodate, per fluorate. Chlorine, fluorine, iodine, astatine, so on, bromine. They're all in groups of the halogens. So we're basically talking about perhalogates in essence. By themselves, the new results aren't evidence for ancient life on Mars. Non-living processes could have yielded identical processes. At a minimum, the study shows how traces of uh, bygone Martians could have survived for eons. Just a little kind of a, you know, basically a little, passing reference to possible microbial life in the past. So basically, it's providing evidence for future probes what to look for. That's what we're getting at. Samuel Kunaves, a Tufts University chemist and former lead scientist for NASA's Phoenix Mars lander, said this is an important finding. There are locations, especially subsurface, where organic molecules are well preserved. In addition to ancient carbon, Curiosity has detected samples of organics that exist on Mars today. The rover has periodically, literally sniffed, drawn in some of the Martian atmosphere and sampled it, tested to see what was on there. Researchers using these data show that methane, the simplest organic molecule, is present in Mars' atmosphere. Methane's presence on Mars is puzzling because it survives only a few hundred years at a time. So when we talk about like climate change, and you hear me talk about how methane is so much more potent a greenhouse gas than CO2, and we always say it's in the short term, it's because it doesn't linger very long in the atmosphere. Certainly not as long as carbon dioxide. But when it is present, it can really kind of do some serious heat retention. So basically, the implication is this gas is being replenished. It's a gas that shouldn't be there. So how is it being replenished? Okay. That's the good question, and that's basically the question that NASA's Jet Propulsion Lab scientist Chris Webster has raised. And he's the one basically makes the point of it has to be being replenished somehow. In addition, methane's observed behavior on Mars is strange. In 2009, researchers reported that inexplicable Martian plumes randomly belch out thousands of tons of methane at a time. Where's it coming from? Webster's latest study, Professor Chris Webster, has also been published in Science, and he basically shows that Mars seasonally, quote unquote, breeds the stuff. So each Martian summer, the atmospheric methane concentration rises to about 0.6 parts per billion. In the winter, this count ebbs by a factor of 3 to 0.2 parts per billion. We don't have seasonal variations in many molecules in Earth's atmosphere, so to have a planet having seasonal variations in chemistry is very otherworldly. And this is Dr. Igan Brody. It's an astounding observation. Webster and his colleagues suspect that the methane comes from deep underground, and temperature swings on Mars' surface enables it to flow upward. In the winter, the gas could get trapped underground in icy crystals called clathrates, which may melt in the summer and thereby liberate the gas. What's making the methane? Your guess is as good as mine. No one knows. Going back to the clathrates. Okay. Clathrates basically contain frozen methrate. That's a huge problem here on Earth. We have some compelling evidence for clathrates in Earth's deep past melting in large volume on Mars, releasing large amounts of methane, heating up the planet. There's also methane hydrates, which is methane and water frozen together. You find this like in the ocean floor, and that's melting, releasing methane to the atmosphere. Climate scientists here have the worry of how much methane is there and what's the rate of it being released. If it's released all at once, that could be catastrophic for the climate and for basically aerobic organisms. Now here's an interesting thing. Okay, let me first introduce to you the term I'm about to share with you and give you its definition. The term is serpentinization. Serpentinization. That is a chemical reaction between iron-bearing rocks and liquid water. Right? We really can't tell if this methane we see today is a current product of serpentinization or microbial activity at some depth. This is a statement from Michael Muma, who is the NASA guarded scientist who discovered Mars methane plumes. Or could it be something that's stored from ancient time that somehow is being slowly released? So, for those who are in the field of astrobiology, this is also exciting news, just as my story on the water plume of Europa and Enceladus. It's incredibly exciting because it shows that Mars is an active planet today, says Caltech planetary scientist Bethany Ehlmann. She is a Mars expert. She was not involved in these studies, however. It's not cold and dead, it's perhaps hovering right on the edge of habitability. But Webster and others stress that the studies themselves aren't evidence for life on Mars. Of course not. The observations we see do not rule out that possibility. It's not a smoking gun. It's a possibility, but it's not proof. Again, compelling, tantalizing evidence. So, how are you going to get definitive answers? Send more stuff there. Send equipment designed specifically to test the stuff, collect the samples, have it settled once and for all. So, the European Space Agency has an Exo Mars Spacecraft that's due to land in 2020, and it will be able to drill more than 6 feet down into pristine Martian soils and examine samples with its onboard, basically a pile of instruments at its disposal. NASA's scheduled Mars 2020 rover is intended to collect soil samples for future missions to pick up and return to Earth. Now that is interesting. Think of the anti-contamination protocols that has to be strictly adhered to, as well as carefully followed and carefully thought out, so that there's no contamination from Earth sources. So the Exo Mars mission is making strides. The mission's Trace gas orbiter arrived at Mars in late 2016 and is currently collecting data that will let scientists map Mars methane, maybe even pinpoint its sources, which will then enable the scientists to basically figure out where to put any future probes down on the surface to answer this question. So, wanted to share that with you. Some really cool stuff going on in the world of astronomy. Thank you for your time. Hey folks, just a reminder to please subscribe and click the bell so you know when I drop a video. Please share my videos, please tell others of my channel and of the work that I do. I also hope that you will consider becoming a patron at patreon.com/Science Talk with Jim Massa, where from time to time I upload videos there exclusively for my patron subscribers. Details in the description box below. Thanks.